Let's continue with the post-midterm materials, which are correlation, t-test, how to choose a sample along with confidence interval. For the confidence interval, it's not included in the project, so we're not going to talk about it. However, it's included in the final. So if the doctor gives you two variables and he needs a correlation between them, for example, he or the R, he asks you about the R, which is the same as correlation, and he needs whether it is linear, it's not linear, it's weak, strong, moderate, positive, negative. How can you do that? So we are going to learn about this. So basically the first thing you do, you go to data analysis, and you choose correlation. Okay, you choose the input range, you highlight the first two with them, all of them, you press enter. You go to labels in the first row, you highlight it, output range, let's put it here, and let's say okay. So we got our correlation, which is the correlation between cholesterol, and cholesterol will be one which is logic. Between triglyceride and triglyceride will be also one which is also logic. Between cholesterol and triglyceride, which is what we need, is 0.64. So we can write R equals 0.649, or correctly it's R small. So this one is this one is the correlation. Let's highlight it so it becomes easy. This one is our correlation, or the R value. Type, what if he asks you give me a scattered plot to show whether it is linear or not? So what you are going to do is you are going to highlight these four. You go to insert, recommended chart, all chart. Actually it's recommended here scattered plot, but if it's not there, so how can you find it? You go to um, scattered plot, and you press OK, enter. So you got this one, and if you see here 0.65, approximately 65, which is a moderate positive linear correlation. So positive upside here, whenever we get closer to one, the all the point becomes closer to each other and they make line. Whenever we go to the zero, we have different shapes. Whenever you go to -1, we are also going to see the points close to each other. And this one shows us approximately something which is a positive moderate relationship or correlation. And as usual, don't forget to do axis titles. We write the axes here and there. For example, here we have it's 2 4 6. What are the values for 2 4 6? We have the highest value here is 14, and the highest value here is 14, so this one should be triglyceride. The y-axis is triglyceride, and the x-axis, the highest point is about more than 10, so the highest point here is more than 10, it will be cholesterol. So the x-axis is cholesterol, here is the triglyceride level. So and you can check that by going to see here, ask you about the construct a two-way scattered plot for these data. It's just the same as we did cholesterol, triglyceride. Question 2, it's just the same. He asks you, is there any relationship, does appear an evidence of a linear relationship between cholesterol and triglyceride level? The answer will be yes, but how strong is it? Just um, you have to do just the same as this table, which is basic mathematical equations, addition and subtraction. You have power 2 here, you add all of them and you get the number. So what we did actually is just a quick way to get this R. We skipped all of these steps which we are going to do in the final, by the way, manually, but not in the Excel. And also if he asks you about do a table in the Excel, it won't be that hard. um, so this one, the R becomes 0.65. If you go to the exercise, we got also 0.649, which is the same as 6.5, 0.65. And yes, that's for the correlation. But let's move on to the t-test. Let's see here the t-test. So if the doctor gives you two equations, or two variables, excuse me, two variables, and he told you do a t-test for them, what you are going to do, actually, you go data analysis, you go down, you have three t-tests, you go t-test, two sample assuming equal variance. Okay, so the first variable range will be this one. Highlight them from the mail, you highlight everything, you press enter. For the variable number 2, you go to the up, you highlight the female, you go down and you press enter. For the hypothesized mean difference, it will be 0. You keep it 0, and you put labels because we did labeled the first two rows there. And the alpha, which is the significance range for us, or the probability of getting type 1 error, is 0.05. You keep it as it is. You go for the output range. Let's say here enter, and you go OK. You got all of the things that you need for males, females, and this is the mean for males, mean for females, the observations. The pooled variance is 4.78. The degree of freedom is 94. If you go down for probability two tails t-test, it is 0.78, which is here not significant because it's less than 0.5. 0.05. For t critical, it's 1.98, which is approximately just the same as 1.96 that we have. So this is the t-test. The last thing is how to choose a sample, which is very basic. If he asks you, I need 5 patients, or you have 100, or you have, let's say, 25 patients, and you need to pick 5 of them randomly or 4 of them randomly. So what we are going to do is actually equal round between, double click. So if we have 25 patients and we need to pick 5, you write from 1 comma 25. You close it, you press enter. So the first one will be number 14. First of all, don't forget to rank all the patients that you have. You have 25, you give a number for any one of them. So the first one will be number 14. This is the first participant. You write anything in any cell in this sheet, and this number will change. For example, let's write dot here, enter, it's a change. So the second participant will have the number of 5. Third one, 22. Fourth one, 9. Fifth one is 25. And if it happens and the number is repeated, we just ignore it and do it again. That's what we did in the post material midterm. Hopefully it's helpful, and inshallah you'll get good grade in the project.